everyone, and welcome to Butterflies, Pinwheels, and Wallpaper 4.4. During this problem, we will try to use the concept of dilations to understand similarity and how to use it to solve problems. Our ACES questions for 4.4, just two of them, 21 and 22, beginning on page 85. But our investigation as we look at it begins on 84 using similar triangles. So in 4.2 and 4.3, we were looking at ways to identify similar triangles. We kind of use our knowledge of similar triangles to help us to solve real-world problems. It talks about similar triangles have the same shape but are usually a different size. You can use the relationships between corresponding parts, same parts of similar triangles to solve measurement problems. So if we want to look at some corresponding parts over here, we have a couple. One of them is that we have a 90-degree, oops, gotta grab my pen, have a 90-degree angle here. We also have a 90-degree angle here. So that's one of the angles that's going to be the same. And as we look here, we can see from here on both of these that these two angles are the same. Well, in a triangle, when you have three angles that have to equal 180 degrees, if two of your angles are the same as another triangle's two angles, then obviously your third angle also has to be the same. Okay, so that's how we know that this is a similar triangle. It says here, for example, the diagram below shows, and below was this picture over here, but I moved it to the side. Below shows a method for calculating the height of an object that is difficult to measure directly. It says to place a mirror on a leveled spot at a convenient distance from the object, back up from the mirror until you can see the reflection of the top of the object, in the center of the mirror. It says the two triangles in the diagram are similar. To find the object's height, you need to measure three distances and use similar triangles. Okay? So I've measured three distances for you. The distance from right below the light to the mirror, we'll say, is 15 feet. And then we'll say the distance from the mirror to the toes of this person is 5 feet. We're also going to say that the person at eye level is 6 feet tall. We want to know what the height is at the top of the stoplight. Well, we have three measurements here. We have the 15 feet, the 5 feet, and the 6 feet. So if we start out with our 15 feet up here, okay, we have our 15 feet, and we also have what we know as our 5 feet. Okay, and on the other side, we are going to be looking for x right here. Okay, 15 and x. And on this side, we know that this is 6 feet. Well, just like we did in investigation 2, when we had 3 of the 4 measurements we needed, we can go ahead and cross multiply. Okay, oops, that's supposed to be an arrow. Not very good. We're going to go ahead and cross multiply these two. Okay, so if we do that, we're going to wind up with 5x, okay, 5x equals 15 times 6, which is 90. Okay, so 5x equals 90. Well, if we divide by both sides by 5, okay, we are going to wind up with x equals 18. Okay, x equals 18, which means the height of the top of the light is 18 feet from the ground. You'll notice that this 15 is 3 times this 5. 18 is also 3 times this 6, so that's part of the rules of similarities as well. Now, as we take a look at the problem, they're asking you to use this same picture. They're giving you different measurements, though, than what I did. So go ahead and take a look here at what they're asking you to do. So sketch a situation. You don't necessarily have to do that. Explain how you know the triangles are the same or similar. We discussed that a little bit. And use properties of similarity to estimate the height of the traffic light. I showed you how to do that. So we'll do this one. B, and then we just have 21 and 22. That's it for Butterflies, Pinwheels, and Wallpaper 4.4. Look forward to your questions and comments in the class.